In addition to the quality of the underlying transport clock in an ASI stream, we're also very interested in understanding what the relative timing of the packets themselves winds up and whether that timing represents jitter. Now, in an SDI signal, the individual samples making up chrominance and luminance, chrominance and luminance, that sample rate is tied directly to the serial bit rate. But an ASI signal doesn't work that way. Instead, the content in an ASI signal, that payload data rate, has no relationship whatsoever to the transport bit rate. Each individual packet is just traveling along, and there's a little bit of room, if you will, around that packet. That's why it's referred to as an asynchronous serial interface. That means that the elements that are riding on that transport clock are themselves, they have their own inherent frequency. Now, that means that if we look at the timing of the packets, the gap between packets, assuming a payload of 19.3 megabits per second, there's a 72 microsecond gap. Well, that means if we choose a packet, and here I've chosen a PCR packet, that's sort of a special case. The PCR packet carries the program clock reference. That's going to be used at the decoder to recover the proper timing of both the audio portion and the video portion of the signal. The accuracy of that extracted clock is very, very important, and it's influenced directly by how precisely that packet lands in the transport stream. Now, the specification for that allows it to be a little early and a little late. The overall jitter, that is, if it's mispositioned, can be plus or minus 25 microseconds. And the accuracy of the extracted clock that is derived from the data carried in the PCR packet has to be at least plus or minus 500 nanoseconds. It's common, especially in an IP link, to see jitter of as much as 25 or even 50 microseconds of the overall jitter. That is quite a challenge in a broadcast plant where perhaps an IP link is part of the processing chain. So that's a challenge we also took on, again, with our 4500 series transport stream processor. If we look at that again, as we recover data out of the data buffer, we're not just going to paste the packets, but we're going to smooth it. And that is going to allow us to take, in this example on the left, you see a 2-minute window of the overall jitter of the PCR coming out of an IP link. It has excursions as high as plus 30 and minus 20 microseconds. The 4500 transport stream processor can smooth those packets and produces an overall jitter on the output essentially at zero. That's important because downstream equipment can misinterpret an overall jitter error and produce timing inaccuracies. Those are a significant problem for a decoder. Our 4500 module helps you ensure that those don't occur.